Hello, welcome to this vlog. Today we're going to talk about factoring. Um, factoring. This is in a series of vlogs for factoring. This is the first in the series. We're going to factor monomials and polynomials, binomials, and things like that. We're going to factor all of those. Now let's back up a little bit. First, we're going to talk about what the word factor even means. Watch here. Okay, now if you think, just what does a factor even mean? A part of an expressed product to show something. Well, it's not expressive, but it's a product, a multiplication. What does it really mean? Now, if you look below this, we have a number 6x cubed y. We have several factors listed to the right of the equal sign. Now it's 2 times 3 times x times y. There's 5 factors within this term. And if you multiply those together, it becomes 6x squared y. Each one of these numbers are factors of that term. Now, what's a factor? What is a factor? It's like having a number, and this number can be divided into numbers, other numbers, right? So those numbers multiplied together become that number again. We'll look at 12, so it's clearer. How should we say this? Previously, we talked about multiplying 2 times 3 and 7 times 8 is 56. Or 2 times 3 times 2 times 2, that'd be 24. We can talk about things like that and factoring numbers. Now we're going to go backwards. We're going to take 24. 24 is 4 times 6. But then 4 can be broken down 2 times 2. And 6 can be broken down to 2 times 3. So 24, as we factor it out to its lowest factors, is 2 times 2 times 2 times 3. Now, we're going to unmultiply. Unmultiplying, you would say. Okay. Now, as we said, we have 12 here. Equals 3 times 4. All right. But 3 times 4 isn't the fully factored form. 3 doesn't have any other factors, but 4 does. 2 times 2. Watch here. So here, 3 times 4, but 4 can be replaced with 2 times 2. So now we see the last line here is 12 equals 3 times 2 times 2. That is completely factored. We cannot break it down any further. Now let's see some more numbers for examples. Okay, here. Each number here has factors involved into it. We'll see 25. 25, how do we make 25 with multiplying? We can divide it by 5, so it's 5 times 5. Okay, I'll write that down now. Now, as you write these factors, hold on one second, I'm sorry. When I write these factors, 5 times 5, think to yourself, can I divide 5 by something else to make it smaller? No. So it's 5 times 5. Now I'll go with 24, example B. 24, okay, I could divide it by, well, I could divide by, well, I know 24 is 4 times 6. We'll go with that. So we have 4 times 6. But I'm looking at it going, 4 and 6, they can be divided down further. 4 can be written as, hold on, 4 equals 2 times 2. And we replace that. Okay, now we have the 6. I can't write my pencil here. Hold on. 6. Well, okay, can I divide 6? Yeah. 6 can be expressed as 2 times 3. So there we go. That's fully factored. 2 times 2 times 2 times 3. I can't go any further. Now we have 6a squared. Now, for a squared, what is a squared? We divide that out. It's a times a. We'll put that down. Okay, now I'll clean it up. All right, on to our D example. Okay, now, for example D, 3 is pretty simple. 3 is its lowest factor. But then x squared is x times x. Y is just y. Z cubed is z times z times z. And that would be fully factored. Now, we're going to talk about prime numbers. Prime numbers means it's a number that cannot be divided by anything but itself or 1. It has no other divisors. So we'll look at our A, B, C, D, and E. Which of them cannot be divided by anything except itself or 1, meaning they're prime? Okay. 1, it's officially prime, but we don't often list it as prime because it's just 1. 51. Let me think. Well, divided by 2? No, I can't do that. Divided by 3? Possibly. Let's look at it. Let's see what happens. Now, 13, definitely. 13 is no other divisors. Okay, so 13 is prime. Nothing else can divide 13 but itself or 1. Evenly meaning there's no remainder. There's no remainder, remainder. So, now for A, 27. Yeah, I know we can multiply 3 times 9. That's 27. That means 27 can be divided by 3. And that means it's not prime. Now, the reason we want to work on recognizing prime numbers is that we discuss factors, and to have something fully factored means all of the factors are all prime. Look at our example B. 24. To be fully factored means all of our factors, 2, 2, 2, and 3, have no other factors. They are all prime numbers. If you have all prime numbers, you know you're fully factored. Thank you, and I'll see you next vlog.